first of all, before starting topic, we should all know where is the Earth's water. As we everyone know that 2/3 is water and 1/3 is land. Out of it, the total global water, 96.5% is in ocean, and 0.0 and fresh water is only 2.5%. If I classify this to fresh water of 2.5%, we can see the groundwater consists of only 30.1%, and surface water is 1.2%, and it is tapped in the glacier, and ice caps is 68.7%. And this surface water is found in lakes, atmosphere, living things, rivers, swamps, and that 1.2% has been break up in this way. Now, basically, in this topic, we will deal with the groundwater. Now, why? Now, what is groundwater? Now, there is a basic assumptions in the people, common people, that groundwater forms a river in the underground, and that is a groundwater. Basically, I'm going in the contrary of this this popular belief. It is simple like a sponge. In a sponge, the water is stored in the pores. When if you dip a sponge in a water, the water will get absorbed in its pores. Similarly, under the ground, also it is filled up in the pores. Water is filled up in the pores of the rocks, sand, gravels, as same as like a sponge. The groundwater is the water that exists underground in the different saturated zones beneath the land surface. The uppermost of this saturation zone is known as the water table. Groundwater generally moves at a rate of 7.70 to 60 centimeter per day in an aquifer. As a result, you can see the water will remain in the aquifer for thousands of years. Now, as I am explaining about the groundwater, let us see the scenario in India. Groundwater is an important natural resource, but groundwater, as we know, the groundwater is being tapped from this underground to meet our daily requirements, such as drinking water requirements and basically the irrigation requirements. As we know, the government of India, in the Ministry of Water Resources, that is now it is called as Jal Shakti, they have started a mission under the name of PMKSY, that is Pradhan Mantri Krishi Shalpa Yojana, and it has an objective of Har Khet Ko Pani. In this objective, they are creating a different source of irrigation water in the different agricultural land which is cultivable, but it cannot be cultivated due to the lack of irrigation water. So government is thinking to cover up all these areas which can be cultivable by providing the irrigated water. Now, how this can be happen? By extracting the groundwater, by creating a groundwater wells and irrigate that area so that the farmers have the benefit to sow their crops. Now, let us see the scenario of India from 1960 to now. Groundwater used for the irrigation was only 1% in 1960 to 61. Now, till 2007, according to the report of the Central Groundwater Board, it has been seen 60% of the irrigation water has been facilitated by this groundwater. And in the rural India, it has been seen 85% of the drinking water sources are also the groundwater. Groundwater irrigation is expanding at a very rapid pace in the India from 1970 onwards. 1970 onwards, if this thing continues, what will happen? India's groundwater, it is a very valuable resource, but it is also a diminishing resource. If current trends continue in the next 20 years, India's aquifer will get into a critical condition. India is the largest user of the groundwater in the world. It has been estimated to 30 cubic kilometers of the groundwater per day, per year it is used. And it is about quarter of the global total as per the report of the World Bank. These are the basic details. Now, as a result, there requires a proper groundwater management in India, that unnecessarily water should not be pulled out, proper recharge system should be there, so that this groundwater can be used in a proper way. Now explain this groundwater system. This is a basic one figure. Here I have shown one artesian well. That means a well which is extracting water from the aquifer. Now what is aquifer? Aquifer this is one impermeable stratum, as I am showing in the screen. This is another impermeable stratum. Between the two impermeable stratum, the water present is known as an aquifer. And this is a confined aquifer, and this one is a sand and gravel where the water can easily pass, and here the water layer has been found. This is the water table for the upper water table, and this is known as an unconfined aquifer, which can be generally seen in the waterways. Now the groundwater wells which have been constructed for irrigation purpose, this can be from the water wells where the motor can be fixed and it can be used, or basically what nowadays is doing, we are extracting this deep confined aquifer water for the irrigation purposes. Basically, today I will discuss all about the irrigation purpose. Now, coming to the deep tube well construction, this construction of wells, this construction of well to tap out the water from this confined aquifer can be constructed with the help of a mechanism. This is also known as a deep tube wells. That is, in short, it is DTW. Now, how this deep tube well can be constructed in the field? It is basically, it has 4 steps. First, we will investigate the land that is known as hydrogeological investigation, to know where the water is present in the underground. Because by walking above the land, we cannot say where the water is there. We have to first do the hydrogeological investigation, where the good quality water in its current quantity of the water is there, where up to which depth we have to construct that well. Everything will be detailed in the hydrogeological investigation. Second, at that point where the borehole has been selected, the point there we will drill a pilot bore well. After drilling, we will create a lithochart. How this lithochart is prepared, everything I will explain in the later part of the slides. Now, then we will design the well and we will construct it, and last is a well development by using of the compression. Now, coming to the first point, what is hydrogeological investigation? There are the different methods of the hydrogeological investigation. Here I am explaining the resistivity logging. How this resistivity logging is done, basically I'm showing. This is the instrument. How the resistivity logging I have done in the site. It is generally in Udaipur area in Tripura, where the resistivity logging has been done. Now, coming to the point, what is resistivity logging? It is a method by which electric current is passed into the through the electrodes. It will be passed, and by determining the resistivity to this electric current, different rocks has different resistivity to the electric current. Depend on how it is opposing the electric current to pass through it. By knowing this resistivity, we can classify what type of rocks or materials, or whether the minerals is present, whether there is gas is present, or whether there is petroleum or water is present. We can classify it depending upon its electrical resistivity. So resistivity logging is a method of well logging that works by characterizing the rock or sediment in a borehole by measuring its electrical resistivity. Now, resistivity is a fundamental material property which represents how strongly a material opposes the flow of electric current through it. In this log, resistivity is measured using 4 electrical probes to eliminate the resistance of the contact leads. The log must run in holes containing electric. This log, I have said about the electrode, it will be dipped in an electrically conductive mud or water with enough ions present in the drill. Now see, This is the equipment of resistivity logging. The well connection is there. Here one electrode is being placed. In the different sections, 4 electrode will be placed. Now the current will be passed through it, and we will measure the resistivity and we will record. Now the distance between the 2 electrodes will be measured from center point. What is the distance between the 2 electrodes? It will be measured. Let us consider it is 5 meters. Then it can scan up to 2 times of the depth, that is up to 10 meters, which we will get by through this surface. How much distance we will separate the electrode, we will increase the electrode distance from the center, and we will get the depth scanning. What is present, what types of rocks is present below. Now interpreting the result, we will get like this graphs. These types of graphs will see over here in this picture in the left hand side. Depending upon the resistivity value, they have classified that this is a shale, this is a porous stone, this is again shale has been there, porous stone, tight sandstone. Like this, we can classify what type of, where the water will be present, and whether there is a porous soil is present, which contains heat, which will be saturated, or what type of, whether it is there is a clay that is aqua fluid which cannot give, or we cannot extract water from that aqua fluid, or whether it is aqua fuse, whether it is aqua tard, or whether it is aqua part, can be classified from this resistivity laws. So the first step, hydrogeological investigation to select a borehole point. This can be done with the help of a resistivity law. Now coming to the second stage. Now here you see the second stage, drilling pilot borewell and litholog preparation. Now first question is, what is litholog? This, in the right hand side of this diagram, this shale, porous stone, this has been classified with the respect to resistivity. Practically drilling, and when the soil sample is coming out, by seeing this, by testing this, we can say what type of material it is. And this is by practical assumption. In the field, we record the data that this is up to this much of depth we got the shale, up to this much of depth we got the porous stone. That is the litholog preparation. With this litholog preparation, we have to design, we have to say how much depth of how much filter we will provide, how much blind pipe we will provide, how much casing we will provide. Everything will come out from this litholog. Now, for constructing the pilot hole, a borehole has been selected from the hydrogeological study. Then we will do the road. Then we will create a pilot hole to a certain dia. Pilot hole will be constructed with the help of this machine that is known as a rotary drilling machine, or sometimes it is also known as a rig machine. Rig machine is also there, by which we will create construct the pilot. Now, how much pilot hole should be created? As per the Raghunath 2007, it has been how much yield you require. How much yield you require? It will say how much dia of the well should be created. And also, if I am to put 10,000 gallon per hour submersible motor in this well, that means it will also have the motor will also have a certain dia. The motor should go freely into it. Considering everything, Raghunath in 2007 has suggested that for expected well yield in liter per minute, that is 400, the inner diameter of the well casing minimum should be 12.5 and optimum should be 50. And by this way, we can how much dia of the well it will be there, how much dia of the well casing should be there, nominal size of the pump bore can be classified. Now, as I have already explained, I'm again going back. Hydrogeological investigation was the first step. Second step is a drilling pilot borehole, that is litholog preparation. Third is well designing and construction. Last is well development. The first part I have finished, the resistive mapping method, that is hydrogeological investigation. Second part, that is pilot hole construction. Now, how much well dia will be constructed? I have got from this Raghunath. Now, come to this point, again I have explained, that is I have constructed the pilot hole, oversized borehole drilled, Now we will identify the aquifer. Now, how I will identify the aquifer? By that litholog preparation. After the creation of the litholog, I will identify the aquifer. After identifying the aquifer, my third step will be install the screen and the creasing. Now, how this will be installed? Now, the fourth part will be the grouting of that well, and the fifth part will be the well development, and sixth part will be now we will do the yield test. That for how much we have designed, and we expected that 400 liter, whether it is coming or not, we have to check by yield test or water sample. Now, for litho, now see over there, for litholog preparation, when the drilling has been taking place, see this photo in the second part in the screen. The samples has been collected in a cup, plastic cups. They have collected the samples after every 20 feet. Let us consider I am drilling. I have created the in the right hand side you just see this is a basic well. Let me consider I have to drill 600 feet, 700 feet, 800 feet, depending upon the water tables and all. By hydrogeological investigation and classified this water level is there up to this depth is good. From that I have classified that I have to drill at least, let us consider for certain area I have to drill at least 1000 feet. After every 20 feet, I have collected the samples and I have prepared the sandy soil, loamy soil. Now, whether the screen is that porous soil, whether the aquifer, when I will get the exact aquifer, I can see from this sampling of the sample, and I can prepare the litholog. Now, come to the basic diagram. Here you see, this is the well. This is the well. This is the well. Here we can generally see this depth is the pilot hole depth. This total depth is the pilot hole depth. After that, what we have done, we have inserted the pipes in it. Now, up to this much, it is the water table. We can clearly see up to this much, it is the water table. Now, the filter pipe. See, this is the filter pipe, which will allow the water to pass through it and fill up in the way, which we will tap out through this way. These are the filter pipes, or it is also known as a slotted pipes. This is also known as a slotted pipes. Now, how many types of this slot is present? We will see. See over here. At first, it is V-shaped continuous slot. The slot shape will be like the V shape, and it is known as a V-shaped continuous slot. Second is a lower type stream. Third is rectangular slot stream, and fourth is the pipe-based wells. Now, coming to the first page, the diagram in the right hand side, you can check. This is nothing but a pipe-based well stream, and this one is a rectangular slot stream. These are all made up of GIs. Now, PVC pipes are also available for shorter depth, like 200 feet, 300 feet. We generally use PVC pipe, and that is also known as small bore tubers, which we generally construct up to 220 feet, 300 feet in Tripura soil conditions, 350 feet we construct, and we put 2 to 3 HP motor in it, which can cultivate up to which can irrigate up to 1.5 to 2 hectares of the land. 2 hectares of the land. It is very helpful for the small farmers who have 2 hectares of uncultivated land, which is cultivable due to the lack of irrigation water. We can use these types of small bore tubers in that land to cover that land, and it will be very helpful for the small farmers. Now, these are the casing pipe, GI casing pipe. think so. Someone has switch on. So this is the casing pipe. Now coming to this point again, in the right hand side of the diagram, we have just said we have created the pilot hole up to a certain depth. After creating this pilot hole, we have identified the water table, and below this water table, we will provide what? We will provide the filter that pipes, GI pipes, slotted pipes we will provide. At the bottom, we have provided a bottom cap. This one is the bottom cap. We have provided. After bottom cap, we will drop one by one pipe, 20 feet each. It should be done rapidly. After doing the pilot hole, after we have created the pilot hole, or after the preliminary washing, we should immediately drop all the pipes one after one. We should not delay. And first, the bottom caps above it, we have provided the slotted pipes one after one. After that, we have provided the plain casing, because this part of the underground is not permeable. It will not give water to you, or it will not have an water. It may be aqua fluid, it may be aqua tar. So unnecessary slotted pipe should not be placed over there. We will place in the zone where the water is present. After completion of this one, we will immediately do the gravel packing. Now, how this gravel packing we have to do? These are the pea gravels. See in the left hand side of the diagram, I have shown this from the stones. These are known as the pea gravels. It looks like peas. And what type of pea gravels we will use? I will come to the later slide. Just now I'm explaining. We will use the pea gravels and fill this space between the casing pipe and the underground mud. We will fill it by the pea gravels. Now, what is the helpful of these pea gravels? I will also explain it. Now, let us first say what type of pea gravels we will use. What are the quality? A gravel packed well is a well having an artificially placed gravel envelope around the well stream that I have provided. The gravel packed material should have a uniformity coefficient less than 2.5. That is D60 by D10 after sieve analysis. It should be less than 2.5. Now, what are the advantages of this artificial gravel pack? First preliminary advantage, it stabilizes the equipment. It avoids main point. It avoids or it minimizes the sand pumping. The sand from the pores, the sand which is present in the rocks, which will come into it will block the filter passage, which will not happen when there will be a gravel filter. If these gravels are present, if these gravels are present, this soil will not be allowed to enter and clog these pores of the filter. It minimizes the sand pumping. It allows to use large screen slot. That means we are using the slots in the screen pipe. We can use a large screen slot with maximum open area also, because gravel will pack it that and the sand will not be allowed to come. It provides a zone of high permeability surrounding the well stream, which increases the well radius. According to the Times formula, we will get an effective radius will be more. So we have understood why gravel packing has been done. After the completion of the gravel packing, we will provide the housing. We will provide the column pipe over here up to a certain depth, and we will provide the motor submerged in the water, and we will pull out the water from this well. Now, again, I'm repeating. What was the first step? First step was hydrogeological investigation. How we have done? Hydrogeological. Thank you, Shudharani ji, for your She has said the very informative presentation. Thank you. Thank you for that. Now, the first step, it is hydrogeological investigation, which we have done with the help of the resistivity logging. Second, it was the drilling pilot bore well, which we have done with the help of rig machine or rotary driller, and we have prepared the litho chart where the water table is present, whether it is correlates with this resistivity logging. And third is well designing and construction. So how much depth of slotted pipes, how much depth of casing pipe we have to use. This I have designed, that I have to say it in the field, and we have put it. And third is fourth is grout the annular space, which I have done with the help of P gravels. P gravels, I have done the grouting. And last is well developed. That is again an important part. How this well development is done. This is basically done with the help of an air compressor. We will fit an air compressor on the mouth of the well, and we will blow a huge amount of air into the well. We'll put a huge amount of air into the well. Now this huge amount of high pressure of the water, air will push this water out of the well. Push this water out of the well, and the air will mix with this water. Air will mix with this water, and it will form a bubbles. It will form the bubbles. What is the main function of the air compressor? Air compressor gives a high air blow to the well, which will mix with this water to form a bubbles, which will have a less density, and it will come up, of the well. By this way, we can clear all the muds which is present in the, or soil which is present in, will remain in the soil, and the slot which this slot will all get cleared out with this air compression. By this way, we will develop the well to give a good yield. After that, by fitting the motors with the help of the column pipe, the submersible motor, as per requirement, it may be 10,000 GPH, 15,000 GPH, according to the well dia that has been suggested by the regulator. We will fit the motor, and we will get the water. Then we can done the water sampling or the yield test, how much water it is yielding out. We can find this. This part is about the groundwater well construction, how it is done. And that next part, and coming to the different parts of the water, so that is river training works. Now, first is why training? Why to train this river? Now, what is river training? River training refers to the structural measures, means construction of the structural thing by which we can train the river or make the river to go through a certain part of it. River training is an important component in the prevention and mitigation of the flash floods, and it also helps to control the flood, as well as in other activities such as ensuring safe passage of a flood through a certain bridge or different structures or different water retaining structures. Why it is necessary to train a river? Because we all know in the North India, these are all the rivers are in alluvial soil, which are more erosive, and the river is highly meandering. In a highly meandering river, one part of the bank will get eroded, concave part will get eroded, and it will get deposited where the energy is less. But it will the sediment will get deposited. As a result, the meander will again get increased. The frequent changes if this meandering happens, it will generally cause a frequent change in the river course, evolution of one river into the another, heavy shoal formation. We are generally seeing this problem. That is diversion of the main current towards the bank, and inside it, one shoal has been formed. In a catchment area, if a landslide occurs and the silt the high silt load came into the river, which will also cause a shoal formation. Aggradation of the river bed, that is high flood levels due to increase of the river bed of adversely high flood levels. Heavy erosion of the banks by hill streams due to frequent flash floods. River instability, change in the bed slopes due to seismic activity, change in the river channels due to change in the rainfall patterns. Now, what are the anthropogenic problems? Degradation of the river bed downstream of a dam or a barrage, effects of constriction of the river width. If I constrict the river width, it will happen. Effects of flood embankment on the regime of the rivers, effects of extraction of sands and boulders from the river. These are the different anthropogenic problems. Another anthropogenic problem is that is effect of creating pakka bathing ghats in that may in Ganga we can see it's a holy place where there will be different bathing ghats has been created as a placing of pilgrimage. These are also some problems. What are the objectives of river trade? What will happen if I do the river trade? It will cause a safe and quick passage of the high flood, efficient transport of the sediment load, which will come as a silt load or sediment load, make river course stable, that it will not highly meander, and it will not cause losses to the property or livelihoods, provide sufficient draft for navigation, prevent outflanking of structures by directing the flow in a defined stretch of the river. If you not do properly river treating, what will happen? The structure will remain one side, the water should pass through it. Now, and after some period of time, we are seeing the water is passing to the another way. The highly meandering river has changed its course, and it is passing in another way. It has created its own way, and the structures which have created, it is remain in the another part. The losses of the economy, loss of economy, loss of property, everything will happen. Now, what are the different river training structures? It will be classified into transverse protection structures and longitudinal protection structures. Transverse protection structure that is being created in the transverse direction, like spars, porcupines, check dams. And this will come, I will come in the later side how this happens. And the longitudinal protection structures installed on the river banks parallel to the river course. How? Bank protection by stone or CC blocks, pitchings, leaves, earthfill embankment, concrete embankment, reversement. These are the examples of the longitudinal protection structures. Now, other protection structures such as sandbagging, canal lining, bamboo piles, these are the other protection structures are also there, which will help to river train the structures. Now, classified based on the action, direct protection work and indirect protection. Direct protection are the ones which are placed directly over the portion that needs to be protected. I need to be protected this bank and this area, I will provide directly into. This is one type of construction, direct protection. Indirect works are the one which modify the flow condition to protect the erosion prone banks. Indirectly, it will change the direction. As a result, this part of the bank will get protected. This is the indirect protection works. Now coming to the different protection work one by one. Now see, this is the slope bank protection work. Now, see, as I'm in the slide, you can see where my cursor is moving. In this part, you can see the GI wires. Inside it, there are different stones, cased in stones. This is sloping bank protection. This I can provide it. These nets are available. These net are of these are known as GI wire threads. These are GI wire threads of the size of 1 meter by 1 meter by 0.5 meter. This can be provided like as in diagram you can see. Inside of it, it will be filled up with the stones, and it will be filled up. This will be the launching part side, and this will be the slope pitching side. It is being done with the help of the threads and the stones. Here I have shown a railway embankment, and this is the highest flood level or freeboard. Up to this much water can arrive, so the erosion cannot take place in the railway embankment. So they have provided the GI wires like this way. This is one kind of slope back protection work with the help of the GI wires. Next, these are used in the different parts of the country nowadays also, but in Tripura it was used earlier days. Now it is not generally used. Bank protection work along with porcupines. These are the RCC pillars, or we can say the sleepers in the railway sleepers, where as I this porcupines is the name came from an animal which has spikes in it. Similarly, this porcupines has been constructed in the river banks, so that when the high flood level comes, it gets strikes into it, and the water gets diverted also, and the bed, this bed does not get eroded out. This is a one kind of protection which is generally used for the bank protection works along the river bed. Thank you, AKM, for sharing your views. Bank protection works. These are the porcupines. Okay. Now coming to the third next slide. This is generally nowadays used in Tripura. That is river bank protection by block pitching. Now, what do you mean by block? These blocks may be of stone. This block may be we can create artificially with the help of aggregate, cement, and water in a certain ratio. That is in the ratio of 1:3:6 or 1:4:8. Practically in the site, we generally construct it in the ratio 1:4:8. These are the blocks. These are the blocks we generally constructed. This is in the left hand side. If I see, this is the launching apron which has been created in the bed in the Gomuti River, in the Gomuti River of Tripura. This is the launching apron, and here in the down picture we can see the slope pitching has been created. The work is not being completed. This was the launching apron side. After that, the slope pitching has been done, which will have, because this is the meandering. We can see the river is changing its course like this way, and it will train the river to flow a certain direction. And in this side, in the opposite side, if you see in the bank side, after this embankment, there is around 200 hectares of irrigation land which has been protected, which was generally get flooded out at every flood season due to the breach of this embankment by this flood water. So the government of Tripura, that implementing agency was the PWD, Public Works Department, Tripura. They have constructed this launching apron and slope pitching. They have trained the river with the help of this. Now, how it is done? At first, we have to determine the scour depth of this area. What is the scour depth? Scour depth depends on the D50 particle of the river bed, and also depends on the discharge of the river and specific gravity of the boulder or stone which I have used. Through this, we have to properly calculate and design how much width of the launching apron should be there and how much slope pacing we should provide. Basically, the launching apron part we should design, and after providing the launching apron, the portion left should be covered with the boulder stones so that it also not gets submerged or it does not get eroded. This part is known as the slope pitching, and this part is known as the launching apron. These are the blocks which practically been done. I have already said these are all in the ratio of 1:4:8. 1:4:8, which has been done. At first, you can see and count it also over here. There are the 6 launching up. These are 6 lines they have provided, and the depth is 5 to 6 layers they have provided over these sections. Before that, we have to provide the random placing. Randomly, we should place, which will cover that scour depth part. After that, layer by layer, I have to provide it. And from this part, I have to make. You can see the right side of the picture. From this part, we have to construct like this the slope pitch. So this is how the block pitching has been. Block pitching is very helpful, and how can we train the river so that it does not get inundated, or it does not breach the embankment, which was a problem in the different part of the Gumti River in Tripura, which has been solved. Now, another method is the construction of the Gabion Wall. Now, what is a Gabion Wall? A Gabion Wall structure is prepared from the pre-assembled rectangular cages like a GI wire press. These are all the cages. See in the right-hand side of the picture, these are the cages. Inside it, we can fill up it with a stone, or we can do the rocks or boulders, or we can provide the concrete part also. Whatever we like, we can use inside these cages. The Gabion structure is prepared from the pre-assembled rectangular cages made of double twisted steel oven. These cages, these are made up of GI wire press, have a double twisted steel oven wire massed filled with rocks, boulders. It is simple gravity retaining structure which retains soil with its weight. It is simply a gravity retaining structure. These types of structures are used in highways, bridges, canal linings, buildings, and it is also used in shore protection works and etc. Now, here I will discuss about the shore protection works. The porosity of the Gabion prevents the pore water pressure also. The water can easily pass, above water can easily pass, and it protects the embankment also. This is the major advantage of this kind of system. The structure blend with the surroundings and allow vegetation to take roots through the structure, which enhances the life of the structure. Reduced carbon footprints are also a noticeable features when compared to the conventional solution. Now, how this Gabion Wall is constructed? Now see. This is a Gabion Wall, first one. This is a Gabion Wall with a better angle. And this is a Gabion Wall with an offset. It's a Gabion Wall with an offset. Now, in the first of the case, this is a ground level, or we can assume this is a water level. So in this side, I will show you how the launching apron is provided, and this is the soil portion. Now, first of all, we have to understand what do you mean by the better angle. We can see the diagram. The Gabion Wall is slightly inclined towards the backfill soil, and this better should be at an angle of 6 degrees. It should be at an angle of 6 degrees. So for a gravity, for the self-gravity, it will not allow the soil to overturn it because of its weight. It cannot overturn it. And we have non-woven geotextile is provided with the help of, and this is another system where the backfill soil has been again protected with the help of an offset. That's Gabion Wall. Lower one is a little bigger. After that, it slightly gets lesser in size. That is step by step, like a staircase. Step by step, this have an offset. Certain offset we have to maintain. It will also protect the backfill soil. The non-woven geotextile will provide the inner side again. These are the two types of Gabion Wall. One is with respect to the better angle, another one is with respect to the offset. Now, direct bank protection work. Direct bank protection work with the vertical Gabion Wall. Now I am coming to my topic, river training. That means, as I have said, the launching apron. Similarly, the Gabion Wall will be used for the launching apron. This will be the toe wall, and maintaining a better angle in the countryside. By maintaining a better angle, I will provide this. And here I have provided it at a height of 1.25 meter each, and last one is 0.65 meter, meeting the topmost level. And this side also, depending on the scout depth, you have to provide it. This is 0.3 mm thick blue stone, and this is the low water level. Up to this much we have provided. After this is also very helpful in the river training or protection of the protection work in the rivers. And in the bottom, you have to be in this side we can provide geofabrics filter. We can provide. Now the next topic is construction of the spars or the dikes. So what are the spars? Spars are the structures constructed on the river bank normal to the dominant flow direction or at an angle pointing upstream or downstream. The upstream face and the nose of the spars are duly armored with stone pitching and apron of proper dimensions. The apron is built with stones in various crafts. The nose may have different angles and slopes to cater for local requirements. They can be used singly or in series. Spars not be enough, and a number of grooves may be required. The spacing, orientation, and length of the grounds are usually decided by the model experiment. We have to perform the model experiment. How many spars should be provided at that area? Generally, the spars are provided like a battery, one after one, one after one, one after one. Like a battery, we have to provide the spars. Now, what are the guidelines? What are the guidelines for spars? As I have said, it is provided like a battery. 2 to 5 spars are constructed in a battery. Should not be used in narrow channels. We should not use in narrow channels, or it will cause erosion in the other side. Spars can be permeable. It may be submerged also. Submerged spar height 1/3 or half times of the water depth. Height of the spars should be less than the bank height. Flow constrictions 20% maximum. I can constrict the flow of the river. I can channelize it. Spacing 4 to 5 times length. How much length we will provide? The spacing should be 4 to 5 times. Nose, upstream, downstream portion of the shank. This is all I will explain that. Now, what are the different types of spars? There are generally 3 types of spars. One is an attracting spar, a deflecting spar, and the repelling spar. Let me go directly to the diagram. I think so. I'm taking the time more times. I'm winding it up. This is an attracting. This is an attracting spar. See over here, I have provided the upstream water is going towards the downstream. I have made it an angle, certain angle. Let us consider acute angle with the downstream side. In the downstream side, I have created an acute angle. So what will happen? The water will come. The water will come and it will get deflected. That is this part of the bank was get eroding out. The water is diverting to the another side. And this is also a deflecting spar. It will deflect the water. So first of all, this side of the bank is get protected. But this is why this is called attracting spar. This will come towards the downstream and it will cause an erosion over this side. This side will be protected, but this side will get eroded. So these types of attracting grounds or spars are generally not used. We generally use this repelling spars or deflecting spars. Basically, most of the time, the repelling spars are used. We generally deflect the river water towards the other side, and as a result, both sides of the river get protected. And these spars can be of different shape. This can be of T shape. This can be like this, and this can be. These are the 3 shapes we generally use. See, these are the spars. These are the spars. This is one spar, and the down portion was the spars. This has been in the Brahmaputra river. And this I have shown you. These are spars which have been created with the stones. So what I have said, attracting spar, deflecting spar, repelling spar. There are 3 types of spars. I've shown you the diagram. I've also shown there may be a different shape, T shape, and this angular shape also. And these are the practical spars. Now coming to the next point. That is, this is another example. We can see over here one LI scheme is here in the left hand side of the picture. This is the irrigation scheme, which trapped this river water into the into right hand side. There is a irrigation land to irrigate that field. Now this is in endangered, and also different livelihood and homestays are also in danger due to flood. And as a primary protection from that flood, so that the livelihood can be saved, and this pump house can be saved, and also the homestays and all can be saved. We have provided the gunny bags. This is a gunny bag has been provided for the protection, and we are like these bundles are provided. Inside it, the gunny bags are provided. Here in generally 5,000 to 10,000 gunny bags were already provided, but this was not enough. After that, it has been decided, after the flood has overcome, it has been decided to construct the block pitching, CC block pitching over this land. It is also in the Gomti River in the Shilgati area of Tripura only, that is present in the Kakraman block. Another, this is basically the river training structure. This is the embankment, efflux embankment, high embankment, where the river water is trained to come into it. This is a launching apron. There we may provide spars, dikes, we may provide so that the river water gets trained in through it. And this is the guide banks. These are the guide banks through which the river water will come. Now, there is one problem of constructing these guide banks. What will happen? This will increase the flow of water. As a result, some fishes, migratory fish, which affects generally the pisciculture. The migratory fish cannot lay eggs in the downstream. They have to move to the upstream for laying eggs. And it has been seen many migratory fishes are getting extinct. So it came a provision to provide a fish ladder, in it, so that this migratory fish can go upstream and lay their eggs easily. And generally in India, there are 1 or 2 migratory fishes are available. One of the fishes which is present, which we can see in Ganga, that is the hilsha. Scientific name is hilsha. Now see, this is the Google Earth map. In the Kosi Mahasetu in Nirmali, Bihar, we can generally see this is the guide path has been constructed. You can generally see. Now, up to this much only. Any questions? Anyone have any problem in understanding the groundwater wells and the river training works? Anyone have any question? Okay. I think anyone have any question? So thank you. Thank you for today's session.
Thank you, sir. It was really an innovative session, and I hope that all the participants has got some input from this particular presentation. And I am very much thankful to respond to us in this very short tenure of time. Hopefully, in near future also, whenever it will be required, we will get your help. Now I am asking the participant if there is any question, any queries from your side to the expert, Mr. Bikram Shaha. We can discuss it in this forum.
Thank you, Jay Prakash ji, sharing your views.
Any queries, any questions from the participant side?
Thank you, Pallavi ji.
So I think there is no query. The presentation is well formed, and there is no confusion about this. So I am again thanking you for joining this session, sir.
Thank you.
And I'm requesting all the participants to meet us again into the same time tomorrow for another lecture session of this FDP, which will be taken by Ms. Dr. Bornali Devnath. Session. So we'll meet tomorrow at 6:30 p.m. into the same meeting link. Up to this, thank you. Good night.
Thank you.
Thank you, sir.